Welcome to this eLearn Security video training lesson on Immunity Debugger. In this video, we will see how to use Immunity Debugger in order to debug and inspect applications. We will see some basic features that Immunity offers to control the flow of the program, stack, registers, and much more. First, let us open Immunity Debugger and inspect its graphical interface. When we start Immunity, we will see the following interface. In order to explain it in greater detail, let us first upload a program and start debugging it. We can load files in a few different ways. The easiest way is to drag and drop it into the main window. For example, let us drag and drop the file named demo.exe. As we can see, Immunity successfully loads it and we start to see more interesting things in it. Another way to load files in Immunity is by clicking on the folder icon on the top. Once the new window appears, we can browse the local computer and locate the file we want to inspect. Another very useful option we can use to debug applications is by attaching Immunity to their processes. By clicking on a file and selecting Attach, we can see the list of available processes. By selecting the process and then clicking on Attach, Immunity will automatically attach itself to that specific process and we can start our debugging tasks. For now, let's use the application just loaded. On the top menu, we have different buttons. As you will see, these are the most used operations that we will use while debugging applications. It's important to know that the keyboard shortcuts are available for each one of these buttons. If we move the mouse over the icon, we can see the associated shortcut at the bottom of the window. As you will see, knowing shortcuts will greatly improve and speed up all our debugging processes. From here, we can restart, stop, start, and pause the debug program. Here instead, we can run operations such as step into, step over, trace into, and so on. The commands that we will use very often are step into and step over. Step into executes one instruction at a time. Step over is similar to step into, but it acts differently if the instruction is a call to a procedure. While the step into goes into the procedure itself, the step over executes the procedure as a unit and then steps to the next instruction in the current procedure. This can be useful if we do not want to instruct the procedure itself, but we want to go to the next instruction right after it. We will see the difference between the two in a moment. Let's now inspect the Immunity interface. The current view on the screen is called CPU, and it is divided into 4 areas. There are other different views that we can use. For example, if we want to see all the executable modules loaded by the application, we can click on the following icon. Here we can see all the modules that the current application loads, their base addresses, sizes, entry points, and more. For now, we will mainly focus on the CPU view, so let's put it back in full screen. Before inspecting each section of the interface, let us start the application by clicking on the play button on the top, or by clicking F9 on the keyboard. The program will automatically start and then stop at the entry point. The area on the top left is called the disassembly panel, and it is divided into 4 columns. The first contains the memory addresses of the program instructions. The second column shows the hexadecimal value of the instruction at each specific address. These are the opcodes of the program. The third column contains the assembly code, while the fourth column contains Immunity Debugger comments. Here, Immunity analyzes the program and gives us more details for each instruction. As we can see, it gives us very useful information for each instruction. For example, it automatically locates the value pointed by the address in the instruction, which in this case is the string that the program will print on the screen. Here instead, we can see that it tells us the name of the function that will be called. As you can imagine, the comment column will help us to better understand the program. Notice that the third and fourth column of this view can be edited by double-clicking on it. For example, if we want to change a specific instruction, we can double-click on it, change its value, and then click on Assemble. The area at the bottom left part of the interface is called Dump. This contains the hexadecimal view of the entire program. Once again, we have the addresses in the first column, the hexadecimal value in the second column, and the ASCII representation on the third column. On the top right area, we have the register section. Here we can see all the registers and their values. Similarly, to the disassembly area, we can double-click on the register value in order to change it. This can be very useful while debugging the application. For example, if we are debugging an instruction that tests if the register is set or not, we may change the value of a register and force a different flow of the program. The last area in this view is called stack. The first column contains the memory addresses of the stack. The second contains the data located at that address, while the third column contains the Immunity Debugger comments. Notice that the memory location at the top is usually the one pointed by the top of the stack, but we can scroll up and down to inspect and analyze others too. Moreover, by double-clicking on the memory address location, we can see the relative offset of each address. Sometimes this may come in handy to calculate the offset from the top or the bottom of the stack. The last part of the main interface is the small white field at the bottom. The input box can be used to execute Immunity Debugger scripts and plugins. Now that we have a basic overview of the interface, let's start interacting with the application. If we check the assembly area, we can see that the next instruction to execute is the following. We can see that the background color of the memory address is different from the others. If we hit F7 or F8, Immunity will execute the following instruction. Let us hit F7 and see what happens. As we can see, the instruction has been executed and the gray background is now in the next instruction. In the registers area, we can see that Immunity tells us which registers have been affected by the instruction. Indeed, ESP and EIP have a different color, meaning that they've changed. Let's now execute a few more instructions until we reach the call instruction. As said before, if we step into this instruction, we will follow the call procedure and we will go into it. If we execute a step over instead, we will execute the call instruction as unit, and we will go to the instruction right after. Let's see both of them to better understand how it works. We will first execute a step into and see what happens. As we can see, the debugger goes into the procedure. Indeed, the next instruction is the one on the top. Let's now see what happens if we execute a step over on the same instruction. To do so, let's first set a breakpoint on it, and then reload the application. To set a breakpoint, we just need to select the instruction and hit F2. As we can see, the color in the memory address column changes. Let's now reload the application and run it once again. We're back on the entry point of the program, but we can also see that the breakpoint still exists. Setting breakpoints is very useful, since it allows us to tell the debugger where to stop while executing the application. Indeed, if we now click on the play icon once again, the application will stop here. Let's now execute the step over and see what happens. As we can see, we are not into the procedure anymore. Instead, the debugger tries to execute the whole procedure block. Since this procedure creates a pop-up window, we are prompted with the following message. Once we click OK, the debugger will continue to the next instruction right after the call. Here indeed, we can see that the next instruction is the following one. As we've seen, the step into goes into the procedure itself, while the step over executes the procedure and stops at the instruction right after. This will be very useful when we want to simply jump onto the next instruction without inspecting the procedure itself. The commands we've seen so far are the most common, but as you can imagine, we've just scratched the surface. Immunity offers a great amount of features and options, and it will be impossible to cover all of them in here. Instead, we'll study them when needed during the next videos and sections. This concludes our training video on Immunity Debugger. Thanks for joining us.